7.2, use the converse of the Pythagorean theorem. Remember converse backwards? Last section we learned about the Pythagorean theorem. Now we're going to learn how to use it backwards. And we start out with a theorem. Theorem 7.2, the converse of the Pythagorean theorem. If the square of the length and the longest side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Basically, you're going backwards. If c squared equals a squared plus b squared, then ABC is a right triangle. Example 1, verify right triangles. Tell whether the given triangle is a right triangle. So I'm just going to put it in the equation. 3 square roots of 34 squared equals 9 squared plus 15 squared. Get out my handy dandy calculator. That's easy. 15 squared. Okay, to square 3 square roots of 34, you sort of distribute this square. So we get 3 squared, which is 9, and the square root of 34 squared is 34. 9 times 34, 306. And does that equal 81 plus 225? Yep. And when they are equal, you say yes. Okay, it is a right triangle. Let's try the next one. That's the hypotenuse. If it is the hypotenuse, it's the longest side, so it should be the hypotenuse if it's a right triangle. I guess I didn't talk about that on this last example. It sort of looked like it, but you can check it out and just do 3 times the square root of 34 is 17 and some change. So the longest side, if there is a hypotenuse, the longest side is going to be your hypotenuse. So let's check this part B. 22 squared plus 14 squared. Oops, I'm still in red. 26 squared. No, not a right triangle. Okay, you try. Remember, your longest side is always going to be your hypotenuse if it is your hypotenuse. And for instance, with number 1, you're just going to do 4 times the square root of 3, which is 6.9 and some change. Now, don't use 6.9 to do your number. I rounded. You don't want to round. I just want to figure out which number is the hypotenuse. So we have, so don't use this. Just use it to see which number is bigger. You have A, B, and C. And here, the biggest number could be your hypotenuse. And let's see, what is the square root of 61? 7.8. So don't use 7.8. Use the square root of 61. And push pause. There you go. All right, lots of words on this slide. Don't worry about it. It's not that difficult. Classifying triangles. The converse of the Pythagorean theorem is used to verify that a given triangle is a right triangle. The theorems below are used to verify a given triangle is acute or obtuse. Theorem 7.3. If the square of the length of the longest side of a triangle is less than the sum of the squares of the legs of the other two sides, then the triangle is acute. So you have the longest side, which, you know, if it were right, would be the hypotenuse, and the shorter sides, which are the legs, the shorter ones. So if what the longest side is less than the sum of the shorter sides, then it's acute. All right, Theorem 7.2. If the square of the leg of the longest side is greater than the sum of the squares of the other two sides, then it's obtuse. So if the square of the longest side is greater than the sum of the squares of the other two sides, then it's obtuse. I wrote these two things on my homework as I was doing it to help me remember. Less than is acute, greater than is obtuse. Can the segments with lengths 4.3, 5.2, and 6.1 feet form a triangle? If so, would the triangle be acute, right, or obtuse? We learned the first part of the problem a few chapters ago. Remember, if you add the two sides It has to be greater than the third. Excuse me. So 4.3 plus 5.2 is 9.5, which is greater than 6.1. 5.2 plus 6.1 is what? 11.3, which is greater than 4.3. Check again. 6.1 plus 4.3 is greater than 5.2. So yes, it can form a triangle. Now, would the triangle be acute, right, or obtuse? Pick your longest side, write it first, and then your shorter two sides. Okay, 4.3 squared plus 5.2 squared equals 45.53. 6.1 squared, 37.21. So, since the longest side is smaller, it is acute. Example 3, the converse of the Pythagorean theorem. You are part of a crew that is installing the mast on a catamaran. When the mast is fastened properly, it is perpendicular to the trampoline deck. So, catamaran, mast, when it's fastened properly, it's perpendicular to the deck. How can you check the mast is perpendicular using a tape measure? Okay, think about it. How do you make sure it's perpendicular? Think of the mast as a line and the deck as a plane. Use the 3, 4, 5 right triangle and the converse of the Pythagorean theorem to show the mast is perpendicular to different lines on the deck. You wouldn't have to use the 3, 4, 5, but it does make it easier because you can reach, you think about if you're standing here, you can reach 3 feet up the mast, right? And measure, and your string would be 5 feet long and measure 4 feet across. Okay, and then do it again. Measure over here, your 5 foot long string, make sure that's 4 feet across. Okay, so first place a mark 3 feet up the mast and mark on the deck 4 feet from the mast. Use the tape measure to check the distance between the two marks is 5 feet. And the mast makes a right angle with the line on the deck. Finally, repeat it. Okay, you can't just do one, I would double check it. Pretty cool. Geometry, very useful in life. You try. Show that segments with lengths 3, 4, and 6 can form a triangle and class the triangle as acute. So the first thing you do is make sure the sum of two sides is bigger than the third 3 times, and then you use the c squared, a squared, b squared to see if your longest side is bigger or smaller. Pause. Alright, yes, it can form a triangle, and I call it obtuse. What if, in example 3, you could use triangles with sides 2, 3, and 4 to verify you have perpendicular lines? That would be the catamaran. Okay? I think that's example 3. Let me check. Yep, so 2, 3, and 4 to verify you have perpendicular lines. Can you use them? So let's just look. 2, 3, 4 isn't a right triangle. So 4 squared, 2 squared, plus 3 squared. This gives me 4 plus 9, which is 13. And 16. It's obtuse. So it's not a right triangle. It's not going to work. In order to verify you have perpendicular lines, the triangle would have to be a right triangle, and a 2, 3, 4 triangle is not a right triangle. Classifying triangles. This is just a summary. You can use the theorems from this lesson to classify a triangle as acute, right, or obtuse based on its side lengths. Make sure you have this part in your notes somewhere. Daily homework quiz number 1. Number 2, 3. Number 4. Very good.